Hi, welcome to another video of thematic lectures. As per the poll, you requested me to upload October 2022 Unit 6 question paper. So as part of that, I'm uploading. So move to question number 4. A student had two species of constant and wire X and Y. The wire X and Y had different diameters. The student measured the diameter dx of the wire X several times using a micrometer screw gauge. Explain one measuring technique he should use. So what measuring technique he should use? Basically, to reduce the effect of random errors, repeat at different orientations along the wire, and he should calculate the mean. So why we need to repeat? To reduce the random errors. So we will answer this question. It's a very simple question. So what we should do? To reduce the effect of random errors, repeat at different orientations along the wire and calculate a mean. So that is the answer for this question. Clear? Question number 2. The student recorded the following measurements. Determine the mean value. So how we will calculate the mean value? D mean 0.31 plus 0.32 plus 0.31 plus 0.33 plus 0.30 divided by 5 observations. Since 5 observations are there, what we should do? Divide it by the 5. So if you are dividing it with the 5, we will get 0.314 mm. And if you're rounding to two significant figures, say it is 0.31 mm. Then what about the uncertainty? So uncertainty is very simple, right? So take the highest value, that is 0.33, minus the lowest value, that is 0.3, divide by 2, and that is 0.015. And if you're rounding to two significant figures, 0.02 mm. So that's about this question. Now move to the B question. The student measured the diameter dy of wire Y as 0.22 mm plus or minus 0.01 mm. He connected a part of wire Y in a circuit as shown. You can see an ammeter, a voltmeter, a variable resistor, energy source, crocodile clip, wire Y whose length is 89.4, correct? The student measured the potential difference V across the wire in the circuit and the current in the wire. He recorded the following values. The voltage in this voltmeter is 4.990 volt plus or minus 0.05 volt. Next, the current through this is, what is the value of the current? The value of the current is 0.570 plus or minus 0.005 ampere. The length of the wire Y in the circuit is also given as 89.4 plus or minus 0.1 centimeter. Show the resistivity of the metal is about 5 times 10 to the power of minus 7 ohm meter. So what is basically resistivity? What is the equation for resistivity? The resistivity is resistance into area divided by length. Resistance into area divided by length is resistivity. So resistance, how will you calculate the resistance? V is equal to I into R. So the resistance is V upon I. So value of V is 4.990 divided by the current is 0.4570. Correct? So this will help us to find its resistance as 10.9 ohm. Now, what is the area? Area is the cross-sectional diameter is 0.22. So therefore pi d square by 4, since it is diameter. So pi d square by 4 means in sense pi multiplied by 0.22 whole square divided by 4 square. And if you're substituting this as the right values, and if you're converting this into meter square, we will get it as, because SI unit is meter square, so 3.8 multiplied by 10 to the power of 8 meter square, because 1 millimeter square is 10 to the power of minus 6 meter square. So you can use that, and you can find its area as 3.8 into 10 to the power of minus 8 meter square. Now you can plug all the values to find its resistivity. So resistance is 10.9 and its area is 3.8 into 10 to the power of minus 8 divided by length. Length is 89.4 centimeter. So 89.4 into 10 to the power of minus 2. And if you're evaluating, we will get it as nearly 4.6 into 10 to the power of minus 7 ohm meter. And it's nearly about 5 times 10 to the power of minus 7 ohm meter. Clear? So that is the idea about this question. Now, in the second part of B question, show the percentage uncertainty in rho is about 9%. So how will you find the percentage of uncertainty? Percentage of uncertainty. So if you want to find the percentage of uncertainty, you can find the maximum value of rho, and you can even find the minimum value of rho, and then you take the difference in that value, and then you divide by the original one into 100. You can easily figure it out, the value of percentage of uncertainty. Let's see that. So we need to find the percentage of uncertainty. So first you find the maximum value of the rho. So if you want to find the maximum value of the rho, we should take the maximum value of the resistance into maximum value of the area, divide the minimum length. The maximum resistance is, the resistance, general resistance is 10.9, right? So even that will also change. The maximum value of R, we will calculate by taking maximum value of V and divide by minimum value of I. So the maximum value of I is 4.99 plus 0.05. 4.99 plus 0.005 divided by the minimum current means 0.457 minus 0.0005, and this will give you the maximum value of the resistance. Still you will get the maximum value of the resistance as 10.9 if you round into 3 significant figures. The sub value you can substitute 10.9 into, then how will you find the maximum area? So if you want to find the maximum area, A max, So A max means pi into D max squared divided by 4. So you know how to find that value D max, because the value of D is 0.22. So the value of D max is 0.22 plus 0.01, and the D minimum is 0.22 minus 0.01. So if you're plugging that value, we will get, I'm writing the answer 4.15 into 10 to the power of minus 8 meters square. And what is L minimum? So the L minimum is 89.4 minus 0.1, and that is 89.3 centimeter. Now 10.9 times this area, max is 4.15 to 10 to the power of minus 8 divided by this L minimum, that is 89.3 into 10 to the power of minus 2. So the value of rho max we will get as 5.07 into 10 to the power of minus 7 ohm meter. Similarly, you can find the rho minimum. How will you find the rho minimum? R minimum multiplied by area minimum divided by L maximum. So R minimum, if you are substituting, we will get still 10.9. Area minimum, if you are substituting D minimum into that, we will get the area minimum. So area minimum is 3.16 into 10 to the power of minus 8 by maximum value of the length. The maximum value of the length is 89.4 plus 0.1. So that is 89.5 into 10 to the power of minus 2. So if you are substituting this, the value we will get it as 4.21 times 10 to the power of minus 7 ohm meter. Now we need to find the percentage of the uncertainty. So how will you find the uncertainty in this row? You take the difference of this maximum and minimum. 5.07 into 10 to the power of minus 7 minus 4.21 into 10 to the power of minus 7 divided by 2. So that value we will get it as 0.43 multiplied by 10 to the power of minus 7 ohm meter. Now, if you want to find the percentage of the uncertainty, I'll add a paper here. So if you want to find the percentage of the uncertainty, that is the change in this uncertainty divided by the original value into 100. So the change is actually the change in the row divided by u into 100. So the change is 0.43 into 10 to the power of minus 7 into 100 divided by the original value. So the original value is 4.6 into 10 to the power of minus 7. So if you are dividing and multiplying it with 100, you will get it as 9.34 percentage. So it is nearly 9 percentage. Hence, we showed it. Next question. The student measured the resistance R1 and R2 of different length of wire using an ohm meter. Each resistance was measured once. The student's value are given in the table. R1 length 40, resistance 4.5. R2 length 9, the resistance 10.2. He calculated the resistance RL for 1 meter of wire using the formula RL is equal to 2 times R2 minus R1. Show that the percentage uncertainty in RL is about 2%. The value of RL is 11.4. So how will you do this question? So if you want to find the uncertainty, the equation for RL is 2 times R2 minus R1. So the uncertainty in RL is equal to 2 times the uncertainty in R2 minus uncertainty in R1. Is it minus or plus? So even if it is plus or minus, what we should do? We should add together. That is the rule. So what is the uncertainty for the RL? So how will you find that uncertainty of RL? Not RL, I mean uncertainty in R2 and uncertainty in R1. How will you find it? I'm giving you some time for thinking. Do it. Did you get that idea? So here, what we should do is, so we should use an uncertainty of 0.05 ohm in value of R1 and R2. So substitute it 2 times 0.005 plus 0.05. That means if you are multiplying this, you will get 0.2. Now, if you want to find the percentage of uncertainty, and change is 0.2 divided by 11.4 into 100. So we will get nearly 2%. That is 1.8 percentage. Got the idea? So this is the technique behind this test. Hope you got the idea behind this. Move to question D. The student wanted to confirm that the metal of the wire is constant. The student compared his calculated values of rho and RL to publish values for constant and the values are shown in this table. Calculated value of rho 4.6 plus or minus 9%. The published value is 4.9. RL 11.4 plus or minus 2%. The published value is 11.2. Comment on how well the students' calculated values confirm that the metal of the wire is constant. You must include calculations in your answer. So what we should do is we will find the upper limit of rho. So the upper limit of rho is 4.6 plus this 9%. That means 4.6 into 9 by 100 times 10 to the power of minus 7 ohm meter. That means 5 times 10 to the power of minus 7 ohm meter is the upper limit. Then the lower limit of rho. So what is the value of the lower limit? So if you want to find the lower limit, the same scenario, 4.6 minus 4.6 into 9 divided by 100 into 10 to the power of minus 7 ohm meter. Similarly, what is the upper limit of R? The upper limit of R is 11.4 plus 11.4 into 2 by 100. The lower limit of R is 11.4 minus 11.4 into 2 by 100. So please calculate this upper limits and the lower limits. So lower limit of R, we will get it as 11.2 ohm. And the upper limit of R is 11.4 multiplied, you can take your calculator and you can figure it out. What is upper limit of R? 11.2, no, 11.4 so this we will get it as 11.628. So what is the lower limit of this rho? 4.6 multiplied by 0.91. 4.186 into 10 to the power of minus 7 ohm meter. So what conclusion you can see? The published value is 4.9. This 4.9 lies in this range. This 11.2, that also lies in the range. So what is your conclusion? You can say that, therefore, both values fall in range, confirming metal is constant. Clear? So that's about this question.